defined in assembly language, we can read it with human language, and that means we can code it. It's never going to be a lot more difficult than our Python, but it does mean we've got a lot of flexibility over what we can do. So my old games console I used to play as a boy, which was the NES, Nintendo Entertainment System, which played the first Mario game. It's an 8-bit console, and that all the games on that games console were coded using assembly language. So the developers would want to squeeze as much possible juice out of that system as possible, and they'd have to have complete control over where things go in the memory and interfacing with particular components. And of course, you're not going to be doing that with Python 3. But of course, we use much more powerful computers. So yeah, it's not feasible to use Python 3 for like AAA games or operating systems and other things like that. It's just too slow. And we'd be using lower level languages like C variants or Java or something like that. But it's still classed as a high level language according to Edexcel. Just for curiosity, just so you know, there's a lot of behind the scenes work that Python interfaces with C about. So maybe a lot of the math is done using C written modules rather than Python itself. So because C is just so much quicker, and Python is getting quicker as well. It's starting to close the gap quite a lot. But languages can be written in such a way which you have much more verbose language, where you might state that this is a whole number instead of just having a equals 3. So you might need to declare what kind of variable it is, and that speeds things up because a computer doesn't need to guess what it is by looking at it. Anyway, so the takeaway from that is we've got high-level languages and low-level languages. Assembly is human readable, and then that would become machine code, object code, which is just binary zeros and ones. So just before we move on, let's wrap it up. So you've got your programs like Python and JavaScript or even Java. They're high-level languages. They might have syntax and structure similar to English, so it can be understood by humans. But all those languages, they would need to be either what we call compiled or interpreted before they need to be compiled or interpreted into machine code. So they need to be compiled or interpreted into machine code before they can run. And assembly code is a low-level language which can control specific hardware components. And then there is something called an assembler. Sorry, let's respell that. Assembler, which goes in between assembly language and machine code, but you're not going to be asked questions about that, especially with the 2020 specification. So let's just shift over to this whole idea of taking a high-level language and making it into machine code. That process is done by a translator. And there are two different types of translator: compilers or interpreters. Okay, so you've got, let me just make some more space here. A translator. And there are two different ones. Compiler and interpreter. And depending on the language, they'll use different translators to get to machine code. Now, you won't need to remember what languages use each, but you do need to know about what the differences are between them. So let's just say Python is an interpreted language, and C and C variants of C are going to be compiled languages. So what are the main takeaways from that? Well, a compiled language translates the whole program in one go. So the whole lot, the whole document, the whole language is going to be done in one go for a compiled language. It's going to be executes faster because it's already in machine code. So faster, but already in machine code. So you might have programs for Windows where you have an .exe file, an executable file, and they're going to run directly on the computer. They're ready to go. So that's one of the key things that's different about a compiler, and obviously a big advantage of them is once you've got an executable file. So let me just write that down. Executable file. So it might be PowerPoint.exe, and then you install it. And you don't need to compile again. You don't need to compile it again. So one key component of this, which is kind of a disadvantage and an advantage, is that it's difficult to access the source code once it's done. After compilation, right? So you could say that's a security thing. I mean, companies can protect their code, I guess. There are some ways of reverse engineering it, but it's pretty tricky, and you're not going to see the original code. So it kind of it does protect the source code in that way, but it also means it's difficult to see what was in the source code and to change it or to modify it. So it's a potential advantage or disadvantage there, depending on how you look at it. So the main takeaway there is compilers, they compile the whole program in one go. They make an executable file at the end of it. It's difficult to look at the underlying code from it. It's just machine code, and it doesn't need to be compiled again, and it's ready to run. So obviously there are big advantages for that. So why would people use interpreted languages like Python? Well, interpreted languages are much easier to test because they're done line by line. So I put line by line. So if there's an error, so easy to check for errors in that sense. You literally, if there's a problem, line by line, it's going to go, oh, line 7, there was a problem, right, we can fix that. So obviously it's faster to edit and collaborate on as well. And you can immediately pinpoint a problem in the code instead of waiting for the whole thing to compile first before checking for an error. I mean, if there was an error, you would find it at the very end after it's been compiled for the compiler, and it might not tell you where it is either. You just have to go through and figure it out. But interpreted languages like Python, it would say, yeah, error, there was a line problem on line 7, didn't work, and then you might have a team going through it and to fix line 7. And because it's translated during runtime, the functionality of the software might be affected, and also the main disadvantage and also potential advantage, depending on how you look at it, is that the code, source code, is accessible. So if you wanted to have something which is publicly available, where you had an open source software, then you might want it to be in a format which is you can collaborate on and work on with lots of other people, different teams. So, but if you distribute it in that way, there might be issues. So you tend not to find software distributed from languages that are interpreted in that way. Companies would much prefer to have an executable file, which is difficult to poke into, and especially for intellectual property. So those are the two differences there. Let's have a look at some exam style questions so we can get comfortable with this topic in an exam context, because I know it's quite a lot of information there. So some low-level programming languages use mnemonics, right? So let's talk a little bit about mnemonics. State the purpose of a mnemonic. Well, when we were looking at our fetch, decode, execute examples, in our primary memory we had the address, and this is RAM, primary memory is RAM. And we had our data stroke instructions. And yes, of course, in real life, these are going to be binary, all binary, but if you were writing assembly language, in fact, I think I'll probably better show you some assembly language. It's probably the best thing, so just give me a second. Okay, there we go. So opcodes, operation codes in assembly language, 0 might signify stop, 1 might be add, subtract, multiply, etc. So they're human readable ways of remembering instructions, and that's how we use mnemonics in day-to-day life, like bid maths, if we're doing brackets, indices, multiplication, division, addition, and subtraction. We'll be using that to remember the order of something, or the notes on a stave, FACE. So we can use mnemonics to help us remind ourselves how an instruction is represented. So let's just write it down. Here we go. To represent an instruction or command, or you could say to make an instruction easy to read or write or remember. You get the mark for that, for sure. State the type of low-level language that uses mnemonics. The only answer here is assembly language. Please don't lose marks by just being lazy. Just write the whole thing out. When in doubt, write the whole thing out. Don't just put assembly. They probably will give it to you, but it's better to have assembly language because that's the correct term. Mnemonics are one characteristic of some low-level languages. Describe one other characteristic of low-level language. Well, there are lots of things you could write here. Machine code is hardware specific. Okay, like CPU, etc. So they can because it's a 2 marker. They can manipulate hardware directly. So you really want to link this statement together with 2 things because it's 2 marks. That's just one way of answering it. There are so many other things you could say. You could say they're highly optimized to make efficient use of hardware, minimal memory. They take a lot less memory. That's why my old Nintendo system was written in assembly, because it require a lot less. I mean, they used ROM cartridges for that, but there'd be a lot less memory needed, because memory was very expensive then. Each line of code is one instruction only, like in the fetch decode execute cycle. We go sequentially down our instructions. You could have machine code does not need to be translated. It's literally the binary. It's the zeros and ones already, so there's no need to translate that. That would be enough. I think there's plenty there to go through. State the name of the high-level programming languages translator that executes a line of code immediately after translating it. So it's asking about translators, and you need to know that there are two translators, and in this case, the one that does things line by line is an interpreter, not in a compiler, and don't put Python in there. Describe 2 ways that a high-level language differs from a low-level language. Well, we've covered quite a few of them already, but if you're describing something, you might want to use words like whereas. Let's type that better to link things together. Okay, you want to link statements together because it's 4 marks. So you've got 2 things, but you want to say you want to say 2 things in each of these boxes. So we could say high-level languages like Python 3 use instructions that look like English. So it looks English like syntax. I'm abbreviating here a little bit. Whereas low-level is binary or machine code. It's not human readable at that point. No way you're going to write. You're going to understand what's going on in machine code. You could say high-level languages are general purpose, and they are not machine dependent in that way. Whereas a machine code will be. They're going to be machine code is specific to the type of hardware you're using and the manufacturer itself. High-level languages they're abstracted from the hardware, whereas low-level languages again use whereas. Low-level like machine code manipulate directly. Manipulate hardware directly, something like that. There's plenty there. It's a nice 4 marker as long as you knew the differences between high-level and low-level languages. And the main thing is there, obviously, machine code is the binary code that's specific to the hardware, the CPU. There's like Mac have Apple Silicon. They'll have their own type of machine code that they want to speak to all their devices. A compiler translates source code into machine code. If the source code is edited, it must be recompiled. Right, give 2 other characteristics of a compiler. So we talked about we talked about the different characteristics of a compiler earlier on, didn't we? We said that it's difficult to access the source code. It's difficult to access the source code, so that might improve security. Errors are reported at the end. At the end, once the whole thing is done, not line by line like an interpreted language. Machine code, or exe you could say as well. The executable file is architecture specific. For example, I can't run an exe file on a Mac computer. They use a slightly different system. Now you can still compile it to that system, but an executable file.exe, that example was for Windows, so you'd have to use slightly different ways of compiling it for a Mac, but the general thing is still the same. It's architecture specific to compile it to, and you could translate the whole program in one go. All in one go. So there are plenty of things to say there, as long as you knew the differences between the compiled and interpreted language. And the main thing is all in one go, executable file, difficult to access source code. That'll be the thing to remember. And then interpreters line by line, good for sharing, but not necessarily the best thing for distributing that software, because people can poke around at the source code. Good, there's lots to unpack with that one, and I hope that gave you some confidence that you might be able to answer some exam-style questions on this topic. Please do brush up on it. I've seen 6-mark questions as well on this before as well, so just be careful. And good luck. I'll see you in the next video.